My topic tonight is the internal combustion engine. Now, from medieval times to the jet age, internal combustion engines have been around in some form, whether it was a novelty item, a means to produce energy, or a means of mass transportation. The internal combustion engine is one of the most useful inventions ever created. By understanding how the internal combustion engine operates, you'll explore the laws of physics, chemistry, and applied sciences. I've been interested in internal combustion engines and how they operate most all of my life. It started back in high school when I took a shop class and also took a 4-H class about small engine repair. I've worked on my own small engines on a farm, and since then I've also worked on all sizes of engines from lawnmowers to diesel tractors. I've serviced, I've repaired them, and I'm by no means an expert. But I do have a working knowledge of the internal combustion engine, the history of the engine, and the application in modern society. Now, internal combustion engines, whether they're steam, gas, diesel, or turbine jet, all work off the same principle. They all are basically an air pump. We'll get into that physics in just a moment. Today, I'll explain how the physics applies to the internal combustion engine, the two primary types of fuel used in modern combustion engines, and the differences between the type of internal combustion engines and how they work. Now let's start with the air pump, or the physics. The ideal gas law states, according to the Energy Education Society of California, that when heat is applied to a gas, it expands and creates pressure. This pressure is then diverted into a mechanical movement that provides propulsion or thrust. The number of steps it takes for this to occur depends on the type of engine. Now we'll discuss the two primary types of fuel in combustion engines. The Office of Energy Efficiency and Renewable Energy explains that these types of fuel are water, used in the form of steam, and fossil fuels that are used in the form of gasoline, diesel, kerosene, or jet fuel. Now, there are several types of internal combustion engines, and each one works a little differently, although they use the same principle. Steam engines that are included in the older steam pistons, such as trains and in the industrial age, and the newer steam turbines used to produce electricity and also used to produce electricity in nuclear submarines for their power. Gasoline engines include 2- and 4-stroke engines. 2-stroke engines are used in smaller equipment such as weed eaters and chainsaws. 4-stroke engines are used in automobiles. Here's an example of this. There are 4 steps to these engines: intake, compression, power, and exhaust. But most mechanics will call them simply suck, squeeze, bang, and blow. It's a simple way to explain the process. Diesel engines use the same type of laws, only they use the law of compression to generate the heat to expand upon the piston, thus converting it into nuclear energy. Shown here, as a diesel engine is compressed, or as diesel compresses, it creates its own heat, therefore not needing a spark plug. Turbine jet engines are very similar to diesel engines. The main difference is they use a fan-like device that consistently compresses the air and fuel mixture. As the gas expands, the pressure increases, similar to air being expelled from a balloon, creating the thrust and the propulsion. An example right here is a simple jet engine showing the intake, compression, combustion, and exhaust, or again, suck, squeeze, bang, and blow. Another type of jet engine takes the energy from the turbine and attaches it to a prop, thus the turboprop jet engine. This evening I discussed how physics applies to the internal combustion engine, the types of fuel used in the combustion engines, and the different types of internal combustion engines and how they function. The invention of the internal combustion engine has provided the catalyst for change and progress in society and provides the means and foundation for most all other inventions ever invented. If it wasn't for the invention of the internal combustion engine, we would not have electricity today, and electricity is used to run our computers. Thank you.